Hello guys, so today we'll be starting with number systems with Venn diagrams, which will be your first unit for your whole grade 9. And what do we know about numbers? So we know numbers are like 1, 2, 3, 4, stuff like that. Yeah. So we can group them. Natural numbers, which go on from 1, 2, 3, 4. So they are positive. Yes. Then you have whole numbers. Now the thing with whole numbers is that it's the same as natural numbers except that it starts with from 0. 0, 1, 2, 3, 4 and so on. Okay? Even this is so on. Then you have integers. Integers are negative. Okay? So you can go from negative 1, like negative 2, negative 1, 0, 1, 2, 3 and so on. And you can go so on, and then you can start whatever way you want. Yeah. Then you have rational numbers. Now rational numbers is something different. Okay, let me explain rational numbers to you. Rational numbers are any numbers in the form p over q where p and q are integers and q is not equal to 0. So that's the definition of sorry. That's the definition of rational numbers. Okay. Now what I mean by that, I can have in rational numbers, I can have something like negative 1 by 2, which is a rational number, where negative 1 is an integer, the denominator 2 is an integer. I can have 5 by 2 also. So examples like this. Next, I have irrational numbers. Irrational numbers. Now, irrational numbers are basically not constant, so they are not recurring decimals. So they are something like, you can say they are pi is equal to 3.14159, something like that. So this is not 3.111, it's 3.14155. So it's not a constant, it's not something that you can write in decimal form pretty easily. They will be in square roots, cube roots. They can be square root of 2 is irrational, cube root of 2 is irrational. You can have pi over 3 root 2. You can have stuff like that. These are all irrational numbers. So they are not integers. They are not integers. Mind it, they are not integers. They are irrational numbers. Okay? And then we have real numbers, which consist of all of the above. So these are all the numbers in existence. Okay. Now, if I have to do it on a Venn diagram, say, the first thing I would do is draw a box. Yes. Then I would, okay, before I go on to that, uh, wait, before I go on to that, okay, I'll explain it to you during this. Okay. So if I say start with natural numbers. Now the symbol for denoting natural numbers is n. Okay. My first circle will be natural numbers. Now outside of it would be whole numbers. Okay. Then would be integers, which is represented by z. Then would be rational numbers, which is represented by q. Now outside of this would be irrational numbers, which is I, and this whole thing is real numbers. I'll explain this to you. So natural numbers 1, 2, 3, 4, as mentioned. Whole numbers consist of natural numbers plus 0. Integers consist of whole numbers and natural numbers, but they also have a negative side to it. Now rational numbers consist of integers, whole numbers and natural numbers. Yeah, integers, whole numbers and natural numbers. Now irrational numbers do not consist of any of these. Okay, irrational numbers are a separate thing. Look at it in isolation because they do not have integers, they do not have rational numbers. They are square roots, they are something different. And real numbers consist of all of this. So this whole box is a real number. Okay, that's it. Now I have some questions for you guys. I'll give you 5 minutes to answer all of these questions. Okay, so list all this. Now let's go with the first one here. Let me use a different one. Okay, list all the sets: natural numbers, whole numbers, integers, rational numbers, and real numbers to which these numbers belongs. Okay, so 7 belongs to natural numbers, whole numbers, integers. So they basically, it belongs to all of these. -2 does not belong to, sorry, this is natural, it's not W, this is N. Okay, -2 does not belong to natural or whole, it belongs to integers, rational numbers, and real numbers. Okay, now the second one. Now I have to draw a Venn diagram with all of this. Place 0, 3, -5, and half. Yeah, sure. Okay, I have this. Place 0. So first look at all natural numbers. 3 is a natural number, so 3 will go here. Then I would have whole numbers 0. Then I would have integers -5. Yes, and then I would have rational numbers, which is half. So this is it, and this is real numbers. So these are all their easy questions. Now let's do the medium ones. Classify as rational or irrational and place them in a Venn diagram. Okay, so I'll just draw the Venn diagram. Okay, just forgive me. So 4 is a natural number. -1 is an integer. 5/3. Then I have a separate box here, which is square root of 3 and pi, which are irrational numbers. Yes, and all of this is real. Okay, 4. Now let me just do this here. If you guys can see, yes, you can. And I can. Every integer is rational. Every integer is rational. Yes. 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 All fractions are integers. Are all fractions integers? No, 5/3 is not an integer. So this is wrong. 0 is a natural number. No, 0 is a whole number. And square root of 2 is rational. No. Yes. Now there's a challenge question. Draw a Venn diagram for rational numbers and imaginary numbers with real numbers. Okay. There's another Venn diagram we have to draw. Now say this is Q, this is, and this is real. Okay. -7 would go here, 1/3 would go here, and 0 would also go here. No, 0 would not go here because 0, look, remember, yeah, 0 actually can go here. 0 over 1, yes, 0 can go here. And here, so these are all rational numbers. Then you have square root of 5 and pi, which are irrational numbers. Okay, square root of 5 and pi. Now explain why every integer is rational but not every rational number is an integer. Okay, so every integer is rational because you can have -4/2, which is a rational number because p is an integer, and P and Q both are integers and Q is not equal to 0 because 2 is not equal to 0. And in those lines of the definition, we can say that it is an integer and a rational number because negative 4 over 2 is negative 2, which is a whole number, a negative whole number, which is an integer. But not every rational number is an integer. Is negative 5 by 2 a whole number? No, that gives us negative 2.5. That is not a whole number. And now we have to give two examples of rational numbers that are not integers. And so just as I gave negative 5 by 2 rational number, or say 133 by say 6. Yeah, these are not integers, these are rational numbers. And one irrational number, root 2 pi is a classic irrational number. So hope all of this is clear. Even though this is not like heavily tested, it would mostly play a role in something called set theory, which we'll do later. It will play a major role there, but in isolation this topic won't be tested. But you need to have a solid understanding of this. It may be asked, but it's a pretty simple topic. You just need to understand the concepts and the theoretical part of it. Thank you.